So today we are going to be talking about choreography based saga in microservices. I'm going to take you through exactly how it works step by step so that you'll be able to understand what happens during a choreographic saga. So this is part of an ongoing research in microservices to see how to optimize and improve performance of transactions across distributed systems in microservices. So let's go ahead to get started. This is not a discussion about Saga, but focus on choreography-based Saga. You can look at the description box below. You can see a link to where Saga, I discussed it in detail for microservices. Again, if you've not subscribed to my channel, hit on the subscribe button so that you get notified when I make new lessons, because I do make lessons every time. Being a researcher, this is what I do to help get the knowledge across to different professionals and enthusiasts and also knowledge seekers out there. So hit the subscribe button. If you have challenges also, do let me know. Try to reach out to me and I'll give you the needed support. So basically, this is how a saga works. We have different services that have data in different places. I want to do a query to aggregate this data. So normal query normally accesses the data in one database, possibly a relational database made up of different tables in different places, in different places in the same database. But in this case, we are talking about a query that joins data between different applications completely. How do you manage a query like that? How do you perform a transaction in that case? And now we are talking about distributed systems, and these applications might actually be made up of database of different platforms, maybe NoSQL like MongoDB, maybe MySQL database, maybe some in-memory database. How do you aggregate or write a query that encompasses getting data from all these databases? And that is what we talk about distributed transactions. The solution to this problem is Saga. Saga is a word that appeared in a paper in 1987. So it has to do with querying data from different systems. So there are two basic ways a Saga works. One of them is choreography based. One of them is orchestration. Now I want to just talk about in a few seconds about this diagram here. So we have two services, and these two services, take them as two different applications, maybe residing in two different countries, two different servers altogether. We have the order service to place order. We have customer service that holds the details of the customer, his credit card, his account balance, and stuff like that, his name and address. So when we have a transaction to place an order, this transaction is going to try to place the order, try to check whether the customer has credit. So it have to go from order service to the customer service to aggregate the data and use before the decision is made. So in a Saga-based scenario, we have the transaction starts with order placement and order service. It's a local transaction. An event is triggered. So an event is triggered and the customer service receives this event. Or the customer application, if that will be clearer to you, receives this event and then performs certain actions like checking the credit limit. After checking it and it finds out that there's enough credit and stuff like that, it triggers another event and the order service gets it and be able to complete the order. So that is what happens in a choreography-based service. Now, this is a simplified one because we have only two services here. It could be many, it could be 5, it could be 10, it could be more. But this is the basic principle how choreography-based saga works. Now, let's take a look at this particular case where we have the order service and the customer service. And let's see exactly what is happening. There is a big picture of the scenario where we have an order being placed by a customer who we need to verify his credit, whether he's able to place this order. So let's take it step by step and see what happens in step 1 going downwards. So in step 1, we have a situation whereby an external event, maybe an input form somewhere, places an order. So now a saga is triggered from outside the saga. Take note of this. So an external event, that is this event here, triggers the saga in the order service, and the saga triggers and starts. So the first thing that happens is this step is taken, a create order event, or a create order event is executed by the order service to create this order by the customer. Okay. Now, when this order is created, it's placed in a pending state or in an incomplete state, or actually, the state might actually be blank. So we are talking about we have this state at this point. So the collection in the order repository will have a state attribute that can be pending, that can be blank, can be completed, can be rejected, and stuff like that. So that is one thing you need to know. We need to have a state in the collections repository in the order service. So when this order is created, actually is created, but is not complete. It's in the pending state. So at this point, the order service triggers an event called order created event. So since this is event-based, choreography is always event-based, the customer service is listening to this event to check whether there is an event that has been triggered. So at this point, the customer service is going to, okay, see, order has been created by the order service. Okay, I need to now do something. The order created event, of course, provides some information, maybe the customer details and a few, maybe the customer identifier, stuff like that. The customer service takes the customer identifier, queries the customer details to check his credit and see if he's able to place this order. I'm just making it simple at this time. So let's take the first scenario is that there is enough credit, the customer is able to place this order. What is going to happen is the customer service, after this checks, triggers an event on its own called credit reserved or credit available. So, and meanwhile, this is what happens before it triggers this event. It tries to reserve the credit, like deducting the amount for the order from the credit limit, from the credit of the customer. It deducts it. So at the point it deducts it and it succeeded, it sends an event or it triggers an event called the credit result. Now the other service is listening to this event, and then the other service is going to catch or capture this event, knowing that the customer service actually have succeeded in reserving the credit. And the other service now is going to complete the order that has been in pending state. It's going to assign it a state called the approved state. And at this point, the saga completes. Now, in another scenario where the reserve credit fails, that is the second service fails now. The reserve credit fails, meaning that the customer service is going to a way to tell the other service that the credit reserve has failed. So it goes on this path. Remember, the credit reserve and credit limits exceeded, they are mutually exclusive, right? So it's either one of them. So in the scenario where there is no enough credit in the customer credit or balance, in this case, this fails, and it fails and triggers credit limit exceeded event. The other service that is listening to this event captures this event, and this order that is created, remember an order was created in a state, is going to now set it to reject. And at this point, the saga completes with a failure. And at this point, we have an order that is created, but is actually rejected order. So this is the big picture of how a choreography-based saga works. Now let's break it down into chunks of 12 steps. And now the focus is on checking the time when the saga started to the time when the saga completed, and knowing the performance by subtracting T2 from T1. It's gonna be interesting. Let's now look at it at this point. It's basically what we already gone through, but in this case we use this schematic diagram to make it very, very simple and clear, and also and so that we'll be able to see all the distinct steps that take place. So step 1 says an external event fires MS1 that changes the state attribute from C1, the state attribute of collection C1 from S1 to S2. So at this point, we have this was previously S1, but it changes to S2. So permit me to kind of, I'm going to just erase it. Okay, so it changes the state of this order. Initial state was S1. This external event comes in, okay, and changes the state of this collection to S2. All right. At this point, the next step is the database is going to save the timestamp. Now, timestamp saving the timestamp at this point is done by the database, not the event, because the database recognizes that an update has occurred and it changes the timestamp, adds a timestamp T1, right? So this is what we have at this point. So at this point, this is where we are. When the update is complete, when this update is complete of these two attributes updated, then microservice 1 or service 1 is going to then fire an event called ms1 state change success. So it actually works in microservice 1, does this successfully. ms1 then calls a method change state to s2. So this, now we are talking about ms1 triggers and events, right? So this event is this event here. That is what is actually happening at this point. So the change state to S2 is an event fired by created by MS1 calling MS2 to change its state or to do the next step. So what's going to happen is step 5. MS2 executes a logic at this point trying to change the state from S1 to S2. It tries to do this. The logic fails. So at this point, this does not succeed. So MS2 is going to fire an event called MS2 state change failure, meaning that it's just saying I can't do this. It's telling the other service now I have failed. This operation cannot be performed in my end. Now MS2 state change failure rolls back the transaction at this point. So this transaction is rolled back. So maybe I can just indicate it using clean up some things. So this transaction is rolled back. Let's see if we can get a pen. To S1. So it rolled back from S2. At time to change field, it rolls back to S1. The timestamp is not necessary for now, but it can also be there. So once the rollback is complete, MS2 is going to fire an event. This time, an event coming from MS2, and it's going to be saying that MS1, please change back your state because I failed. Therefore, you need to take note of this and change back your state or to state of the collection to S1, how it was before you tried to do this. So at this point, MS1 is going to execute a logic at this point. In response to MS2, it's going to, at this point, change back the state of this from S2 to S1. So that is a rollback operation or a compensation operation. All right. So this is at step 10 in where we are. So at this point, we are going to have a timestamp T2 after this rollback change of state in MS1 is complete. So at this point, we have two timestamps, T1 and T2. All right. So what is going to happen is we take T2 minus T1, and that will help us to have an idea of how long the saga takes to complete on a failure condition. Not a successful one, but a failure condition. So this is basically how a choreography-based saga works. Now, we have all the steps I've outlined here. It's very, very clear and easy to follow. Take note of it, try to copy it down, get your head around it because this is something interesting and I'll be making more updates on this. So I'd like to thank you for viewing and I would like to say the next class I'm going to be talking about orchestration based saga, which is the next type of saga used in microservices. You're also welcome to subscribe to my channel. I think this subscribe button is going behind me, but I'd like to recommend you subscribe to my channel by hitting on the subscribe button below, and let me know if you have challenges, or let me know whatever topic you would like to learn, and I'll be there for you. I'm Kind on the Tech Pro, and we'll see you in the next lesson.